Hello everyone and welcome. My name is Pradeep Kumar Wala and today we are starting something really exciting, a complete step-by-step journey through system design from absolute beginner all the way to mastery. This is topic number one and the question we are answering today is the most fundamental one of all. What is system design? By the end of this video, you will have crystal clear understanding of what system design is, why it matters more than almost any other skill in software engineering, and how it is used by companies like Netflix, Google, WhatsApp every single day. So let's dive in. Before we jump into the deep end, let me quickly walk you through the what we will cover in this one topic. First, we will define system design in plain, simple English, no jargon, no complexity. Second, we will use the powerful analogy comparing system design to building city. Once you hear this, it will click forever. Third, we will look at real companies, YouTube, Twitter, WhatsApp, and see exactly how system design made or broke them. Fourth, we will cover the two types of system design, high level and low level. Fifth, we will go through the seven pillar of the universal framework every engineer uses to evaluate any system. And sixth, we will look at the diagram showing how systems evolve as they grow from one user to 1 billion user. Alright, so what exactly is system design? Here is the definition I want you to remember. System design is the process of how to build software so it works reliably at any scale for one user or 1 billion user. Let me make this concrete with a story. Imagine you want to build WhatsApp. You open your laptop, write some code, and it works great for you and your five friends. Fantastic. But now 50 million people want to use it. Suddenly, your server crashes under the load. Messages get lost or delayed. The app becomes unbearably slow. Your database can't handle billions of messages, and if your one server goes down, everything stops. Everything. This is the exact problem that system design solves. System design answers the hard questions. Where do we store the data? How do we handle 1 million requests per second? What happens if server crashes? How do we make a fast users in the Japan and Brazil at the same time? How do different parts of the system talk to each other? These are not the coding questions, these are the architectural questions, and that's what system design is all about. Now, I want to give you an analogy that I guarantee will make system design click in your mind immediately. Think of system design like urban planning for a city. When city is built, planners have to make huge architectural decisions before single building goes up. Where do the roads go? Where is the power grid? Where are the water pipes? How do you move millions of people efficiently? Software systems are exactly the same. Roads and highways in the city, those are the network and APIs in your software system. The path data travels through. Post offices, those are the messages queue. System like Kafka deliver information reliably between different parts of your app. Libraries, that's your database where all the knowledge, all the data is stored. Traffic police, that's your load balancer, making sure no single road, no single server gets overwhelmed. Local shops near homes, that's a caching and CDN, bringing commonly needed things close to where the people are so they get it fast. Power grid backup, that's a fault tolerance, your backup system that keeps everything running even when something failed. Here is the key insight. A bad city has one road for everything. When the road gets congested, everything stops. Traffic jam equals complete collapse. A well-designed city has highways, local roads, bypasses, traffic signals, so everything keeps flowing, no matter how many people show up. Software work exactly the same way. Nothing makes system design more real than looking at the actual companies. So let's look at the three legendary example. YouTube 2005, three guys in garage, one server, a simple PHP application worked great. Then it went viral overnight and the server crashed because nobody had planned for scale. Today, 500 hours of video are uploaded to YouTube every single minute. 2 billion active users, thousands of servers, multiple data centers on every continent. What changed? The core idea. Share video is the same. The code is similar. What is completely different is system design. Twitter 2006, a single Ruby on Rail application, one database, very simple. But as it grew, the server couldn't handle the load. The site would crash so often that fail whale, a cartoon of whale being lifted by birds, become an internet meme. People would literally expect Twitter to be down. Today, Twitter handles 350,000 tweets per minute with near zero downtime. How? A complete system redesign, caching layers, distributed database, and messages queue. And then there is a legend WhatsApp. Only 50 engineers and they were handling 900 million active users. Think about that. Facebook had thousands of engineers, WhatsApp had 50, and they were competitive. Facebook bought WhatsApp for $19 billion. Why? Because the exceptional system design choices, the right database, the right messaging protocols, and the right server configuration. System design doesn't just affect performance, it affects the value of your entire company. Now let's talk about the two main types of system design you will encounter. The first is high level design or HLD, the big picture. HLD is about what component exists in the system, how do they connect to each other, which database are we using, do we need message queue or cache? It's an architectural overview, the blueprint. HLD is typically done by the architect and the senior engineer who are planning the system before the development start. Second is LLD. LLD is the detailed picture. LLD is about what the classes look like. What does the database schema look like? Which table, which column? What are the exit API endpoints? Which algorithm are using for a specific function? LLD is done by the developer who are actually building the component. Think of it in this way. HLD is the blueprint of house, showing rooms, floor, layout. LLD is the wiring diagram, the plumbing map, and the material list. Both are essential, one without other is incomplete. This slide covers something really important, the seven pillar of system design. This is the framework every engineer uses to evaluate any system anywhere. Pillar 1, scalability. Can system grow as the number of users grow? Netflix started with a few thousand subscribers. Today it serves over 200 million. Scalability is what makes that possible. Pillar 2, reliability. Does system keep working without failure? Think about bank transaction. You cannot afford to lose data. The system must be reliable. Pillar 3, availability. Is the system always accessible? When we say system has a 99.99% availability, that means less than 1 hour of downtime per year. Amazon Web Service target 99.99%, that's a less than 5 minutes per year. Pillar 4, performance. Is it fast, low latency? When you type something in Google, results appear in under 1 second. That's not magic. That's a years of performance engineering. Pillar 5, consistency. Does everyone see the same data? When you check your bank balance on your phone, then your laptop, then an ATM, you see the same number. That's a consistency. Pillar 6, security. Is data safe? Are passwords encrypted? Is there a protection against attack? This pillar is non-negotiable. And pillar 7 is cost. Is it affordable to run at scale? A brilliant architecture that costs $10 million a month is not a solution. Good system design is a cost aware. Every time you design a system, every single time you evaluate against these seven pillars, this becomes your mental checklist. Now let's look at one of the most important diagram in the whole of system design, how system design evolve as it's grow. Stage 1, just starting. You have single server doing everything, the application, database, file storage, all on one machine. This works for maybe 100 users. It's simple, cheap and fast to build, but it has one catastrophic weakness. If that server goes down, everything goes down. Stage 2. You separate the database from the application. Now your app server and your database server are different machines. They can each be scaled independently. This gets you maybe 10,000 users. Stage 3. Add load balancer. Now instead of one app user, you have multiple server 1, server 2, server 3. The load balancer distribute incoming requests across them. If one goes down, traffic goes to others. No single point of failure. This gets you to the millions users. Stage 4. Add cache and CDN. A cache like Redis store frequently access data in a memory, so you don't hit the database every time. A CDN serves static files from location close to your users. This is how you handle 10 millions of users. Stage 5. Full production architecture. Now you have CDN, API gateway, load balancer, dozens of microservices, database cluster, messages queue, cache. This is how companies like Uber, Netflix, Amazon operate, serving hundreds of millions of users. Here is the key insight of this entire diagram. The code changes little, system design change completely. This is why system design is the most important skill to master. Let's talk about what happens when you get system design wrong, because the consequences are real. No caching, your database get hampered with 100 times the necessary request and crashes under the load. Single server, one hardware failure means complete outage for every single user. No load balancing. One slow request blocks the entire pipeline for everyone. Wrong database choice. You end up unable to query efficiently with potential data corruption. No rate limiting. One bot, one bad actor with a script can bring down your entire platform. No backup. A single hard drive failure means permanent total data loss. And here is the real world example that show how just serious this is. Knight Capital, a financial trading firm, in 2012, due to bad software deployment, system design, and operation failure, they lost $440 million in just 45 minutes. The company went bankrupt. This is why system design is not just academic, it is literally the difference between success and catastrophic failure. Now let's make sure you are prepared for the interviews, and these are the most common system design questions you will face at the very beginning of any interview process. Question number 1. What is system design and why it is important? System design is the process of defining architecture, component, interface, data flow to satisfy the given requirement. It's a critical because it's determine how well systems scale, perform, and stay relevant under the real world condition. Question number 2. What is the difference between HLD and LLD? HLD is the overall architecture, which component exist, how they connect, which technologies to use, and LLD cover implementation detail, class diagram, database schemas, API contract, specific algorithms. Question number 3. What are the key non-functional requirements in the system design? The seven pillars: scalability, availability, reliability, performance, consistency, security, and cost. These are also called quality attributes of the system. Question number 4. How do you approach system design interview question? So here is the way to answer system design interview question. First, you should clarify the requirement, both functional and non-functional. Then estimate the scale. How many users, how much data, how many requests per second. Then sketch the high level design. Then deep dive into the key component and then identify the bottleneck and purpose solution. Memorize this 5 step framework. It works for every system design interview questions. Alright, we covered a lot. Let me quickly summarize the 6 key things to remember from this topic. 1. System design is the process of planning how to build scalable, reliable software. 2. Think of it like urban planning. Architectural decisions shape everything downstream. 3. The same app idea needs completely different system design at different scale. 4. HLD is the big picture architecture. LLD is the implementation detail. Both are essential. 5. The 7 pillar scalability, reliability, availability, performance, consistency, security, and cost. 6. Bad system design has real consequences from crashes to company bankruptcy. In our next topic, topic 2, we are going to deep on client server architecture. We will understand how literally every application on the internet communicate. Your browser, your phone, every API call, all of it run on this foundation. You don't want to miss it. If this video helped you, please like and subscribe. It helps this series reach more engineers who need it. See you in the topic 2.